Hello, I'm Leo. I'm the CTO of Sismo, and I will run this workshop on ZK badges and ZK attesters. So first, what is Sismo? So Sismo is a modular attestations protocol that issues ZK badges, which are soulbound token. And it's super modular that everyone can create new ZK badges, and even you can create new smart contracts. We will see that after, that can change the rules to mint these ZK badges. So first, what is a ZK badge? A ZK badge is a tokenized attestation. That means that someone, a wallet that has this attestation proves something about his identity. For instance, imagine a wallet that has a proof of humanity ZK badge. It proves that he's part of the proof of humanity registry without revealing exactly who he is inside this registry. So it's a soulbound token, which is a non-transferable 1155 contract. It's deployed on-chain, and it's minted by a ZK Attesters, which is also a smart contract deployed on-chain. And our goal is to be compatible on all EVM chains and to be deployed on all EVM chains. So how this badge minting process works? So you have a source account, you generate a ZK proof in your browser for privacy preserving reason. You will send this to a ZK attester, which is a smart contract, and the ZK attester will decide, verify the request, the ZK proof, and will mint a ZK badge on a destination. So there is no link between the source account and the destination account. So the first ZK attester we have created is called the Hydra S1. It's an attester that works around, so it's a ZK attester, and that works around group membership. So you prove that you are part of a group and to have your ZK badge. So what exactly is this 1155? It's a collection of token ID. So you have token ID 1, token ID 2, token ID 3, etc. And all this token ID is a ZK badge where all the owners of the ZK badge is inside. So it's a little bit like an ERC20 with a total supply, and each owner of this token has also a balance. So you can imagine that you can have some, I will explain this later, but you can have some different balance between the owner, something like level 1, level 2, level 3. So what is very modular here is that our first ZK attester has a range and it has the right to write into this badges contract to, for instance, collection ID 1 to 1 million. And you can have other attesters with some different rules that can write to another range. So for instance, here we could imagine an attester that just verify and so this attester can be not DK. For instance, you can have a centralized attester that just verifies signature, or you could have an attester that will just verify a Merkle proof on chain. So it's a public attester, and all is here. So yeah, I want to make a demo of our app, and then you will understand more what we are doing. So here we are on the Sismo app. So first, you can see our curated badge. I will explain this later. So here is the proof of humanity I told you about. So we can click on it and see that it's see all the eligible accounts. So it's a group of eligible accounts. We can see the contents. So basically a JSON. And we'll see how when it was generated the last time, like a snapshot, and when it will be the new generation. So to start with, we need to sign in, and this sign-in will be used to decrypt your vault, because we have the Sismo Vault product where you can import all your source account and your destination account to avoid to sign for each when each time you want to prove that you have a source account in a group of eligible accounts. So I'm going to do it right now. So now I'm signing. So in the browser directly, I decrypted my vault, and then I can see that it's a little bit like a password manager. So I can see my sources account that I have already imported. I have addresses, and I also have a Twitter account and a GitHub account that is imported. I can see that I am eligible for different badges. And I have my destination account where I minted ZK badges. So the other ZK badge I want to show you is this one. It's ZK badge sorry, I just need to refresh. It's a ZK badge we use for our DAO because we have a governance to curate the ZK badge. So we have a more permissionless environment where everyone can create new ZK badge very easily, and they can, for instance, for experimentation. And then we try to create this ZK badge thanks to our DAO with some voting. So here in the Sismo contributor ZK badge, it's owned by Sismo contributors, and we can see that we have 21,000 eligible accounts. And if we inspect it, we can see that we have different value here. And those value will give different balances on the ZK badge. So I'm going to show you an OpenSea. So here it's all the owners that minted this ZK badge. And we can see here that, for instance, we have 3 items. It means that you are level 3. And if I scroll here, I can see that I have level 2 and etc. So this will then be very helpful if, for instance, for our DAO, we use snapshots, and we can give different voting power depending on the balance of your ZK badge. For instance, we can see here that we have 500 voting power for some vote here. So we see Adrian again, and some other have just 50 voting power. So yes, and now let me show you, I created a ZK badge for this workshop. So it's a Sismo workshop ZK badge. And we have only 3 accounts for now, but if you want to send your address or your GitHub account or whatever on the chat, we will be able to put them after and to regenerate the group. So it can be really nice. So I'm eligible because my source account here is inside the group. I can then choose a destination. I'm going to choose another one and mint my badge. So what happened here, we are downloading all the group of eligible accounts. We are generating the zero knowledge proof directly in the browser for privacy preserving reason. And when the ZK proof is generated, it's sent directly to a relayer. So let's go back here to the presentation. So what we have created is an app, a no-code tool to let everyone create new ZK badge. So again, I will show you that. So here it's the factory.sismo.io. I've just filled already all the description, name, and so here you have all the metadata you want to fill for your ZK badge for the OpenSea part and for the visualization here. And you can also create here your badge. So for instance, we will do the ZK badge again. So let's do this like that. We can also change the ZK drawing. Yep. And here we go. So we need a badge creator for public contacts, for maintenance. We can have some links. So here we can see that we have links to the ZK hack. And what is interesting here is to add the group of eligible accounts. We have different ways to do them. So we can use groups from existing badges. For instance, we could use the Proof of Humanity ZK badge. So let's add it. We can also use a union operator to add another group, for instance, by uploading directly a list of accounts. So here I could add, for instance, my Sismo address here, and I can also use what we call data providers. So data providers are some APIs that will query some data from outside. So for now, we only have a GitHub and POAP. So in the POAP data provider, you can select a specific event ID. And on the GitHub data provider, you can, for instance, get all the contributor of a repository. For instance, here, I can get all the contributor for our Sismo protocol. And yeah, all the groups that will be generated will be constituted of all this group of eligible accounts. So now I want to show you, so this is really a no-code tool for everyone, but we have also another version, which is a repository, which is called the Sismo Hub, where you can directly code how you are going to generate the group. So it's a TypeScript code where you can call different data everywhere and do operation around it. So there is a tutorial, and in this tutorial we will launch everything for you, all the infrastructure with something like with a Docker, and you will be able to totally generate all your group and all the infrastructure in local. Then you just have to create a pair to send this pull request, and it will be merged, deployed on our permissionless environment. So in the tuto, you will see, so I will just show you some interesting part of the tuto. So the purpose of this tuto is to create a ZK badge for all ENS contributors. For instance, we are going to get all the voters on ENS snapshots space, and also of all the contributors to the repository. So we have the ENS domain and ENS contracts. So in this part, we are reusing our Hydra S1 ZK attester. To have all the parts that we are needed, we need to code the group generators, how we are going to generate our group, which update frequency we are going to give them. And we also need to put the badge metadata we want, the name, the description, the image. So let's start with the group generators. The group generators, it's an object with a generation frequency and a generate function. So here it's really easy group generator. You just have so it will be generated just once, and you have directly your data that are hard written. So it's not really interesting one. We can see here that we have the value. It's the value that will be encoded in the balance. So for instance, if I put it here 2, when I mint my badge, I will have a balance of 2. So this is how you can encode different level on your ZK badge. So here we see that we have hard-coded the data, but what we want to do is to use a lot of data providers to query our data. So we have BigQuery provider, GitHub, GraphQL, JSON. We can also have all our followers in Lens, in our POAP, all the attendees of event. We also have subgraph providers and snapshot to get all the voters. After we have queried this data, we can also union them or make some intersection. So here is a more complex group, and we have a generation frequency of weekly. That means that the generate function will be executed each week, And we see that we first get all the voters from the snapshot provider. We get all the contributors from the GitHub ENS domain repository, and then we made the union of these two groups. So in the tutorial also, you will see that you can generate your group in local. You can send the group to your local chain. So it's not really send the group because it's a huge group, but we will see after it's a Merkle tree, and you will send the root of the Merkle tree on chain. You can also visualize your data with the API. So for the badge metadata, you just have a JSON, and you have to enter the name, the description, and the image that you can put also on your pull request. So at the end, you have something like this once deployed on OpenSea, for instance. And maybe you have some question for this first part.
Leo, just a quick thing. I don't know if you see the Q&A under the chat. There's chat and then Q&A.
Okay.
See that? If you click on that, there's actually 4 great questions. Just be sure to read them out for the video after.
Yes. So what are ZK badges used for? Problem you are trying to solve. So what we are trying to do is to let people import their reputation without making a link between the wallet. For instance, you have a lot of data. You have a lot of data that you have made from your private wallet, and now we have ENS, so we can have public wallet, and you don't want to make link directly between your private wallet, where you have all your bank account, and your public wallet that is a facing wallet. So with zero knowledge proof, you can import directly your reputation from your private wallet to your public wallet. You can also import a reputation from Web2 provider, for instance, from your Twitter followers, from your GitHub reputation, and all of this with privacy preserving way. So could you explain the login process a bit more? Is it done through a Chrome app? So the login process is just you are going to you sign with your MetaMask, for instance, a message, and this will be used as a way to decrypt your vault. So it's a little bit like a password manager, and so all is decrypted directly in your browser for privacy reason. So what is an attester? An attester is a smart contract that is deployed on-chain and that will have the right to write to the ZK badges, to the badges contract, and depending on its own rules. Okay, so let's go for the next part. So in the next part, it will be more technical. We will dig a little more into what happened directly. So I told you that Sismo is a modular attestation protocol. So what exactly is an attestation? An attestation, so here you can see the difference between a ZK badge and an attestation. The ZK badge lives in the badges.sol contract, it's an 1155, and the attestation lives in the attestation registry.sol contracts. It's 2 different contracts. In fact, the badges contract is totally stateless. It reads directly on the attestation registry the state. And so you can have more data in the attestation registry. For instance, you can have the issuer, so which ZK attester issued this attestation. You can have also a timestamp. If we take here the proof of humanity ZK badge, the proof of humanity, it's a registry, and after 1 year, I think you are expired, so you need to renew your proof of humanity registry profile. And so we can ask for the ZK badge to have a timestamp of less than 6 months, for instance, and to ask for the user to renew his ZK badge. You also have some extra data that you can use in the future to encode with the ZK attester more data. So here it is. So here we have the Sismo contributor ZK badge I show you at the beginning when in the app demo that we are using for our DAO. And we can see that we have another value, so a value of 2, and the balance will be 2. So that's how we are doing this. So we read directly the state on the attestation registry. So if we take our core contract, we have the attesters that record attestations into the attestation registry, and we have the badges contract, which is stateless and read directly the data on the attestation registry. So now let's take a look into our contract. So the attester.sol, it's an abstract contract which will be implemented by each attester. So for instance, the Hydra S1 ZK attester I told you about, which is the first one we have developed, inherits from this attester. And what is why we did that? To just only let you in order to have only 2 functions to write. So it's really easy to do. You have the build attestations function where you have your request and the proof. You can directly just decode the data depending on the proof you are using. So is it a zero knowledge proof or another type of proof? And you have the verify request where you are going to verify that a request from a user is valid. So is the request from the user well backed by a proof, and is this proof valid? And this is where we can see that we have different type of proof. For instance, I told you about the ZK attester we have, the Hydra S1. It's a ZK proof, but we can have an attester which works with a centralized parts, something like, for instance, a Degen score that just sign some Degen score for you, and it's not privacy preserving, but you will have just a signature here to ACL recover. We can do also some Merkle proof. So this generate attestation, it is in the abstract contract, and we can see that we first verify the request, we build the attestation, and we then record the attestation. We have some hook before where we can do some stuff I will show you after. So, okay, now we are going to dig a lot more into the Hydra S1 ZK attester on how it works. So just I'm going to take a look at the question. So I have one, besides Twitter and GitHub sources, can we also use Facebook, Instagram accounts as sources? And yes, we could. So we can, I will show you how it works in the zero knowledge part. So it's a circuit. We will see that after. But we can import like OAuth providers, so like Web2 providers compatible. So yes, it's possible. So there is another question from Luis. What stack are you using for generating and verifying proofs? So I will show you after, but it's Circom, and I will show you how we implemented this. So another question from Julian. Can we also use conditional logic when we build a ZK badge based on other ZK badges? For example, have at least 2 out of the following 5 ZK badges. Yes, exactly. That's why we want to have all these ZK badges in the same place, because you can reuse them and have some logic. Like in the future, we can imagine to have some Sybil resistant ZK badges, some DeFi more reputation ZK badges, etc. And we could combine them to do some other stuff. Like the idea is really to have a cryptographic primitive, which is a ZK badge, and everyone can build on top of it. So, okay, now let's, I have another one. Yeah, this one. Do you have some cool dApps? Do you have some cool dApps which are using ZK badge to do something? So we released our protocol in June, and we don't have dApps which are using it already. It's more used to show on some profile for now, but we are integrated with Guild. And yeah, if you have idea of the apps, we are going to launch some cool stuff in next month of the apps that integrate ZK badges. But we could imagine, for instance, with Lens, it's really easy to integrate because it's an 1155. And for instance, in the Lens protocol, you have the Lens module, the follower module, and you could directly ask, I don't know, for someone to follow you to have this type of ZK badge, or for someone to comment on your post to have this ZK badge, for instance, to have a proof of humanity or another one. So yes, let's continue with our Hydra S1 ZK attester. So we will dig more into the ZK part here. So a ZK proving scheme, we have a prover and a verifier. So the prover makes the proof, sends this proof to the verifier, this ZK proof, and the verifier will just know if the proof is true or false. So it will send back yes or no. So to be, for instance, imagine I have a secret and I want to prove to a verifier that I know the secret I use to generate the hash of a secret. So without zero knowledge, I would need to give him the secret that he can compute the hash of a secret and well verify that it's good. With zero knowledge proof, I can compute this hash of a secret inside the prover part, send the ZK proof, and the verifier will just have to verify the ZK proof along with the hash of a secret, and it will tell you if it's yes or no. That means if my secret was valid or no. But I will keep my secret safe. And what is really interesting here is that the prover part can run on a browser, and the verifier part can run directly on a smart contract, so on Solidity. And to do that, we can use Circom and Snark.js. That's really, really interesting tools for zero knowledge, and let you develop all of that. That's what we used. So now I'm going to explain you what happened exactly into our Hydra S1 ZK attester and into the ZK circuit. So we can imagine this ZK circuit as a very safe environment, like a program where we will do a lot of different operations inside it. And when we run this program, all the input, the content will be private, and we will be sure that we well executed each part of the program. So for instance, this is really that we will run into the browser of the user, and we will be sure that he well verified each step. So what we want to verify here for the Hydra S1, we want first to verify that our source account is inside a group of accounts. We want also to verify that the user owns the source account and the destination account. So why is the destination account? Because we don't want a user to send his ZK badge to another user, but it's just the rule we have decided for our first ZK attester, and you could very easily create a new ZK attester that does not have this rule. And finally, we want to nullify the source account. So what does it mean exactly? Once you once you have generated a ZK badge from a source account in this Hydra S1 ZK attester, we want to compute something which is called a nullifier. So you may have heard about that in Tornado Cache or in Zcash. It will avoid to let you create a lot of different ZK badges on a lot of different destinations. And this is very useful because, for instance, if you want to make an airdrop or whatever, it will be CBL resistant. So the nullifier will nullify the use of your source account for this ZK badge. So now we will dig a little bit into each part. So here you can see what is a group of accounts. We see it a lot of time during the presentation. This source of account, to prove that we are part of a group, we can make a Merkle tree and having a proof of inclusion, a Merkle proof of inclusion, to know if we are part of the group, of the set. So here we will just transform this group into a Merkle tree, and we will send the root on-chain. So the verifier that runs with the prover will be able to verify that it's the good Merkle tree that was used inside the prover and inside the circuit. The other part is to verify the ownership of the source account and the destination account. So in general, when you want to verify the ownership of an account, you just make a signature. So it's an ECDSA signature. And the problem is the ECDSA signature is very hard to run inside zero-knowledge circuits. And it's even more harder to run inside the browser because a zero-knowledge circuit can be really costly in terms of CPU and time consuming. So what we have made for that, we have created what we call the commitment mapper and an off-chain commitment system, where we will, so the user will generate a secret that will stay in his browser, and he will just save this secret in his Sismo vault, the encrypted Sismo vault that he owns, and he will generate the hash of a secret. So it will be like a commitment. This hash of a secret and the ECDS signature will be sent to the off-chain service that will be verify the ECDS signature and will send back an EDDSA signature and keep the hash of a secret and the account together. So you can only have one secret for one account. We will map the commitment, which is the hash of a secret, with an account. And then with the EDDSA signature and the commitment and your secret, you and only you will be able to verify the ownership on your zero-knowledge circuit. And so that's why we can also have GitHub and OAuth providers and all of that, because we can just map your GitHub account with another hash of a secret. And again, for Twitter and for all OAuth2 type of identity provider. So for the nullifier part, we want to generate something like a number, but it can't be the hash of your account because it can be brute force. So we want to have something like which is linked to your account, but that no one can guess. So if we hash the secret with another value, for instance 1, we will have this nullifier, because each time you use your account, you will need to use also your secret, and so it will be the same secret we use in the ownership and in the nullifier part. So all of this is done in the same circuit. So that means that we are sure that we verify all these steps inside the same proof. So now that we have our zero-knowledge circuit, we will split it in two parts. So we will have our prover parts that will run in the navigator, and we will have the verifier parts that will be deployed on chain. So maybe before next, I will just answer some question. So can we use it as open API? I don't really understand this one. So will I be able to import wallets of such blockchains, for example, Aptos, Darknet, to my account, which so now we can import ECDSA signatures, so Ethereum account, for instance. We can import Web2 providers, so we have Twitter and GitHub, and yeah, so Aptos, and I'm not sure if it's not ECDSA signature. Really like the Dimitri questions. So where do you store the Sismo Vault? So the Sismo Vault it's an helping tool for UX reason, because otherwise you will need to import your source and to sign each time you want to generate your ZK badges. So what we did is that just you import all your source. So you have all your source that is inside this vault, and it's encrypted with your signature you made. And the result of the signature is the thing that will encrypt the content of the vault, and it's then saved into your local storage, and it's saved into a server of chain to help you recover your Sismo vault if you if you lose your computer, or if you just want to open it in another one. But all is totally encrypted with your signature. So yes, let's continue. So in the Hydra S1 ZK attester, you have, so here we saw that we have our circuit that was split in two parts. We have the prover part and the verifier part. So here we see the Sismo frontend where the user can execute some program, and we saw on chain which are the smart contracts. So you have the zero knowledge attester, Hydra S1, and the verifier that is deployed. So when you want to prove that you are part of the proof of humanity group and to have your proof of humanity ZK badge, you will download on your browser all the group, so all the Merkle tree of the proof of humanity. You will generate the ZK proof with the prover we saw before. This ZK proof is really a Hydra S1 ZK proof, and you will send it on chain to a ZK attester, which is a Hydra S1 ZK attester. So this ZK attester will verify the ZK proof to the verifier, and then we'll also ensure that the root of the Merkle tree corresponds to, so we use in the prover the good group. Also, we will have this nullifier that we computed in the Hydra S1 ZK circuit, and we can save it on chain. So if I reuse my address to generate another badge, the nullifier will just block because I've already used my leo21.his, and it will be exactly the same nullifier. But when we saw this nullifier, we just can't guess that it was the leo21.his address that was used. So you can directly dig into our Hydra S1 circuit here. All is open source. You have also a documentation and the repository. So maybe we'll take a look at the question. So Amir, I think exactly which data related to this process is placed on the blockchain database. So I think so here we can see that it's only the ZK badge, which is an 1155 token. You had to. Okay, so very interesting question, Derek. Can smart contract wallets be the source account and destination account? So right now, we are not compatible with smart contract wallets, but we are working actively to be compatible. The problem we have here is that we need we need an ECDSA signature to verify the ownership, and in the case of the smart contract wallet, we can't do that. So yeah, we will be in the future. So another interesting question from Adam: can the user revoke a ZK badge from the destination account? So here I will show you in the next slide that we can create. So in this Hydra S1 ZK tester, the first one we have deployed, we can't revoke the ZK badge from the destination account. But I will show you after that we can very easily revoke, and we are going to upgrade our contract to be revocable. So it's what we call an account-bound ZK attester. I will show you after. So okay, let's continue. So now I'm going to show you the contracts. It will be fast. So we see that we have the verify request and the build attestation. So in the verify request, we are going to verify our zero knowledge proof request. So here you can see that our proof data is just bytes. So we just have to decode our bytes depending on our proof, and then to validate our input by verifying the root on-chain, that is on-chain, the root of the Merkle tree. And we need to verify the proof, which is a snap proof. So we will call our verifier contract to verify this snap proof. Also, we have some hook around our record attestation. And with this hook, we are going to use a before record attestation to save our nullifier. So here we can see it. So we are just going to take our older nullifier to see if it's already associated to a destination. And if we want to change our destination, so to mint again another badge in another destination, it will revert because the nullifier is already used. Then after that, we can just set the destination for nullifier. So it's a mapping where the key is the nullifier and the value is the destination. So now I'm going to talk to you about our Hydra S1 account-bound ZK attester. So this account-bound attester, the idea is that, so here we use the first one. So the idea is that you will be able to burn a ZK badge that is already in a destination and to mint it again in another destination. But when we do this, we will have a link. So it's not privacy preserving. This operation is not privacy preserving because all is on-chain. So we know that the burn and the mint happen in the same transaction. It's really easy to know. And but it's really interesting if you want just to switch your ZK badges because you have a security issues or stuff like that. So the other thing we are going to implement is what we call a cooldown. The idea is that to avoid to just mint, burn, mint again, burn again, etc., you can do just once for some time, and after that your nullifier will go in a cooldown duration, and each ZK badge you can customize what cooldown duration you want. So here again we see our before record attestation, and we see that we can really modify it to first check, are we trying to change the destination? If we are trying to change this destination, are we already on cooldown? Yes or no? And if we are not on cooldown, we just delete our previous attestation. We set our nullifier on cooldown, and we can just continue our process and to record the new attestation. So we just moved our ZK badge from one address to another one. thanks to our proof. That's why we call it account bound, because from our ZK proof, which is made thanks to our source account, we can change our destination account, and only the owner of the source account can choose which destination is a ZK badge. So you can build on Sismo, all is open source. We have put a lot of effort in our documentation. So yeah, you have also here all our link, and I will go to the question. So can smart contract wallet be the source? So I already answered to this one. Can the user revoke a ZK badge from the destination account? So the account bound attester, I think that answers this question. Does Sismo have a business model? So not already yet, but we will have it in the future. Do you have any other question, maybe? So thank you for your time. I'm just waiting for other questions.
Hey. Yeah, if anyone has further questions, just remember to put them into the Q&A. Also, Leo, just a quick aside, like, are you giving people badges? Because I'm seeing a lot of addresses being put in there, but I don't know if I missed something at the beginning.
Yes. I did a demo where you have a group of eligible users, and I am only eligible for myself. So I ask them to just send their address, and I will update the group of eligible users after the workshop.
Cool.
So
okay. So if there's any listeners out there, you might want to add your ETH address in the chat. We'll have to grab that somehow from Hopin afterwards for you. Some people are putting their GitHub as well. Is that also okay?
Yeah. You can directly edit or make a pull request. And sorry, I don't understand well the question. Yeah, you can send a GitHub account directly, or a Twitter account too.
Okay.
Oh, yeah.
Cool.
So another question from Luis, ENS address 2. So yes, sure, because when we generate the group, we just resolve the ENS address to the full address.
Did you see the latest?
Yeah, can you spin spontaneously an idea around educational Udemy Skillshare with Sismo app? So yeah, now it's really easy to create new ZK badges. So we could imagine like when you, for instance, with this ZK hack, we could imagine that when you resolve a puzzle, or where we could have all the resolve a leaderboard, and we could use the leaderboard to directly generate a group of eligible users for a ZK badge, and it will be fully privacy preserving. So you could then use this everywhere you want. So I think for educational, and it's really interesting to just show that you have made some stuff. So another question from Alexander: could you do an unlinkable revocable badge by having a secret that verifies that the last badge was burned? Perhaps it would have to use is state root in the proof. So that the last batch was burned. So yeah. So what we can do, so verifying the Ethereum state tree the battery set tree is very, very complicated in zero knowledge. So maybe you will see that with the ZK EVM, but it's very, very complicated to verify this in the zero knowledge proof. So what we can do is just, we have a subgraph on top of our attestation registry, so we can just create another group and do like recursive like that. So another question from Ivan that is interesting: for burn and mint, can you batch them up to preserve privacy? 20 users burn and mint at the same time. Yeah, it could be interesting, but yeah, it's I like the idea. We need to investigate in this. So badges represent proof of membership and proof of ownership. So it's a proof of membership of a group of accounts. And so inside, to make a proof of membership, you need to do two operations: a proof of inclusion inside this group and a proof of ownership of the element you want that you own that is inside. So it's a proof of membership, basically. So yes, question from Alejandro. What do you envision will Sismo be able to unlock with these novel privacy tools? It feels there will be a breakthrough related to this technology. So yeah, we can imagine a lot of different applications. So now we are just giving the primitive to let everyone build on top of this. So we are trying to create a very powerful infrastructure on top of this. I show you the factory and all of that. Yeah, the idea is that you can direct leverage your identity, like with self-sovereign identities and stuff like that. You can directly have your own data and just share what you want when you want. Like you can share the data you want and really select what you want to reveal and not reveal everything. Currently, you can't do that actually. So that's what we are doing. We are trying to solve. So a question from Benedict. Thanks for the talk. Who generates the Merkle tree and who updates it? It is a central authority, right? So all is made on our GitHub repository, so you can check all what happened, and it's public. The data is publicly verifiable, so everyone can just verify the group of accounts, the root, and check if it's valid or no. So this is the idea.
Are there any more questions? Did you get that last one?
No, sorry, I was. So is it possible to export our chat to have all the?
Yes. Yeah. So I'm gonna look for that after. But somebody asked, I don't know if you already answered this, but where does the name Sismo come from? Have you answered that one?
Yeah. Where does the name Sismo come from? So it was around seismograph and stuff like that. So it was a really a brainstorm session. Like
nice.
So that like the ZKs, they have some antenna, and they are the ZKs is here. So we have you can see this one. It's two different ZKs, and the idea is that you have a little bit like signals. So you have different sources and different destination, and you just aggregate the data you want from your sources and you put them other. So it's like, yeah, that's what the idea.
Nice. Cool. I don't know if are there any other unanswered questions there? If not, I mean,
I think we are okay.
Cool. So I want to let folks know that we've turned on the networking function over on the side. Maybe first, though, a big thank you, Leo, for this fantastic workshop and sharing with everyone how to use Sismo, what they can do with it. I know people are very excited in the chat. There's a lot of addresses in there. I guess, yeah, where can people find you after if they have more questions? There's Twitter.
Yeah, we have a Discord. We have so you can come to our Discord. So maybe I'm going to send the link. Sorry.
Sismo.io? Or
yeah, it's Sismo.
Great. Cool. But yeah, thanks so much for this great presentation. And
thank you for inviting
me.
me.
It was really fun to get to do that with you guys. Okay, so we're trying something out. There's this networking button over on the, I don't know if I'm pointing the right way for you, but over on the left of the page. It's like a 3-minute speed networking kind of tool. So you'll just get matched with someone random who's here. If you don't like it or want to jump out, I think you can like quickly leave and come back, but maybe you can meet some cool people that way. Obviously be respectful, but yeah, if you want to check it out for a little while, we're going to be back here in, I guess, like 10-15 minutes with the team from Scroll for our second workshop. But thanks again, Leo.
Thanks, bye.